Doing time error measurements is fairly simple and should take no longer than a few minutes. The first thing that you need to do is check whether you have the license for doing OTA synchronization measurements. For that, you need to go to the system settings and check in the license activation if you have the OTA TE software options. To do so, go into the module options and verify that there is a green check mark in the OTA TE. That means that we have the necessary software license activated. If you don't have it, just check with the EXFO team to activate it. To perform over-the-air, OTA, time error measurements, you need to be in the 5G signal analyzer mode. Simply click on the modes and select the 5G NR signal analyzer. The first thing you need to do is to demodulate the SSB signal of a 5G channel that you want to characterize. If you don't know where the SSB is located, you just need to perform an SSB scan in the desired frequency range to find the location of the SSB in the GSCN raster. Click on the frequency menu, followed by a click on the SSB scanner. After that, select the parameters that you want for the search and click on Start Scan. Now, depending on the search conditions, this search could take up to 45 seconds for every 100 MHz of frequency range. Once the SSB is located, click on the play button and the SSB will be demodulated. Now you can see figures like RSRP, RSRQ, and SINR. If you want to add time error figures, you need to go into the synchronization menu to activate the TE feature. For that, click on the clock, and you can activate the time error measurements. Once activated, and if the unit is recently started, you should wait around 15 minutes for the synchronization module to be disciplined. You can see if the GNSS reference is locked and ready by clicking on the small satellite icon that is on top right of the screen. You can see that the icon is shown in green. Click on the satellite icon to enter the GNSS menu. Here in the GNSS menu is where you can select the constellation that you want to use for the GNSS reference. You can select GPS, Galileo, GLONASS, Baidu, or all of them. Then you can select the band. You can select the L1 band, or L1 plus L2. Additionally, you could configure the cable delay that you have in the GNSS antenna. Depending on the cable length of the GNSS antenna, you need to add more or less compensation. And finally, you can also configure the desired accuracy, ranging from very high, medium, to low. Down below, you can see the information of all the satellites that are being received by the GNSS antenna with the amount of power being received by all of them. And then on the right side you can see that there is no alarm for the jamming. You have now the time locked and the GNSS is ready to do the measurements. You can now go back and see that you have figures for time error as well. Once the GNSS is locked, you need to compensate the distance from the antenna. Over-the-air time error is defined as the time error in front of the antenna, but it is unlikely that you are just in front of the antenna. You therefore need to compensate the distance between the 5G antenna and your location. To do so, click on the Distance Compensation button and add all the PCIs for which you want to compensate the distance. You could enter the distance if you know it or if you can calculate with a laser pointer, or you could eventually introduce the coordinates of the base station, which is a parameter that it's usually known, and then the distance will be automatically filled for all the PCIs. With this information, you can go back to the main page and read the time error figure. In this case, the time error being measured is out of specs, meaning that the MNO does not have synchronization protocols activated in the network, or the PTP protocol is not being propagated for whatever reason.